Very good morning. And Assalamualaikum and salam sejahtera to all. You guys able to hear me? Right? Okay. Thank you for the thumbs up. That is okay. So before we start, perhaps we can there's one question that I can address. Hi sir, do we still have tutorial later at 3 p.m. Will be physical or online? Okay. Thank you for the question. As my usual answer is that unless there are any announcement that is turned into online, it should be always physical. Okay. So at 3 p.m. we still have a physical one. But to one extent is that what I can say that today will be the last session for my lecture because I think I can finish up the last two chapters, which is chapter 11, 12 and 14. Okay, so perhaps at the end of this session, you won't able or you would have to attend another session, which is supposedly next week, because I think that most of you will be away for your holiday already, right? So what I would like to do for today is that I will try to cover both two lectures. Okay? Basically, it's on the management and also on the security part. Okay? So that is what I will do. And then also for those who already or perhaps those who wanted to have replacement quiz, okay? So you have to pull your back after this, okay? For another 10 minutes, okay? So you can actually take your replacement quiz. Okay? So anybody wanted to have any replacement, because this replacement it will cover the full cost itself. Okay, so if you have already took 3 quizzes, okay, and then you didn't able to sit for one of it, okay, so you can do the replacement. Okay, so all total quizzes will be 4. Okay, so the weightage is actually 10%. Okay, so that can actually at least help you with the 2.5% of your marks. Okay. On announcement, on assignment, basically, we already give you some information, and in some of the labs that I've handled, I've also have explained what you need to do. Okay. What are the things that perhaps you need to address. Okay. Basically, it is based on how you can design your network architecture. Okay. That's the first step. Then how do you manage the addresses, IPv4 addresses, using what they call VLSM, variable length subnet mask, right? And later on, what I also address is to some of the students is that perhaps you can look into what we call VLAN, virtual local area network, because in the same location, okay, you have few groups, different groups that and that different group also have some similar groups on other locations. Okay? So that is how you can use VLAN later on, right? What else? Assignment done or already being released, already been discussed, some of it. Okay, I think the lab test also have been released yesterday by Dr. Chan. So perhaps you can look into it, and if you still have problem or still have question, please inform me. And for that lab test, is an individual one. You'll be able to discuss with your friend, or you can refer to any references. There's no problem. Okay, but you have to adhere to this the question that been given to you. I think one of the criteria is that you need to the question is based on your last ID number, okay, and also the IP addressing is based on your birthday, right? So that are the criteria. So please meet that criteria, right? those under me, they will need to submit. I will actually have this Google group submission later on, right? All right. So before that, I just want to touch a bit on right. So I just want to touch a bit before we move on the teaching evaluation percentages. Okay. As mentioned to you guys that this is an important exercise. Okay. So I would like to thank everyone. So for this lecture, basically we have 57.69% that already do the evaluation. I think today is the last day. Still able to do the evaluation if you wanted to do. Okay. And I request most of you or all of you to do this, right? But for the lab itself, I think for lab TT6L, perhaps if you are in here, I'm not so sure which one, but the TT6L, if you guys are in here, so please make sure that you do a few more. Okay. Currently, it's invalid because it's less than 50%. So I hope that you'll be able to do this exercise today. All right. So for today, we will start with chapter 12 itself on congestion control and QoS. Okay. We have looked into the different layers, right? Where we look in this 7 TCP/IP layer. You have the physical, you have the data link, then you go to your network, transport, and application. Okay. And the purpose of a communication network is that you want to make sure that the information that you have can be transferred to the intended end user. So what you need to do is that you need to get the information. Okay? If it's on the physical layer, it means that you send bit by bit. And then on the data layer, you want to make sure that it is being transferred based on host by host and so forth going up, right? So the next thing that we need to address is that how do you make sure that the traffic, which means that sending the packet, okay, if you have a single user, then that is very much simpler to deliver. But if you are talking about hundreds, thousands, billions of users that communicating throughout this network, okay? So how do you make sure that the network is not being congested? Okay? So that is the task that we have for today. So I have 1 hour to do that. And then the QoS basically is the kind of agreement between the network and also the user, okay, or application itself on things that they have to comply or things that they agreed upon. For instance, the quality of service for the network is that you can transmit data with a specific rate, but the application wanted to have higher than that, so they need to negotiate, and if they can come to some terms, okay, then they will actually do the transmission, or else it doesn't meet the requirement for the quality of service by the network. So the network will define that, okay, and the application will also have some of their requirements that they need to make sure that the application or the service that they are trying to serve, they will be able to do that with a respective manner. Right? So that is what we will go in that for today. Right. So the first thing that we will see is on the traffic pattern, congestion control strategies, how you shape the traffic, okay? Emission control and maintain network stability and performance. Then acquire the knowledge and skill to design, configure, and manage quality of service. Policies to prioritize and ensure consistent delivery of critical data, application, and services, improving the overall quality of the network communication. So these are the learning outcome. But what we can see is that how do you manage the traffic? Okay? This is similar to the one that you have car traffic or things that related to your daily life when you commute, right? So same thing, okay, because you have a lot of other requirements, you have a lot of other things that you have to consider, okay, so that you're able to do this and make sure that the network doesn't really contest. Okay? So that is what the idea behind this chapter itself. Right. So we will look into traffic description, average data rate, peak data rate, maximum burst size, effective bandwidth, then open loop, closed loop, and so on. Okay, so these are the things that we will look into, right? So we will start with the traffic. Okay. So what we are having right now is what we call packet switching techniques. Okay. So compared to previous one, which is based on voice communication. Okay. Phone telephony type of thing. So now we are actually involved to what we call a packet switching techniques. Yeah? And basically, the data that we transfer is based on packet. Okay? So main focus of congestion control and service quality of service is for data traffic. And this data can be being different characteristics. Okay? So you can see that for video calls, we usually read it as a variable data rate. If it's a voice call, perhaps you have a fixed data rate. And if it's an internet type of thing, it's kind of a bursty data rate, right? So how do you manage this? Okay? So in congestion control, we try to avoid traffic congestion. And in quality of service, we try to create an appropriate environment for the traffic. Okay, so that is the two different things. Is that how do you manage the traffic? One thing, this is kind of the law or the that managing the traffic, so that you don't go into that trouble of having this traffic congestion by identifying, by giving some specification between the service and the network itself. Okay, so these are the two different things that we define here. Okay. And for traffic itself, okay, there are some characteristics, and these are the things that are usually being looked after, okay, when you define by the services, by the network itself, or by the designer of this network. Okay. So, for instance, they will discuss about average data rate, okay, where is being defined as the number of bits sent during a period of time divided by the number sent in the period. Okay? So average data rate. Okay? Then peak data rate, what is the maximum data rate of the traffic? Okay? So what is the most or the biggest size or the biggest chunk of your traffic that you can actually transmit? Okay? And then maximum burst size, okay? Maximum length of time the traffic is generated at the peak rate, and eventually the effective bandwidth is the bandwidth that the network needs to allocate for the flow of traffic. Okay? Out of this, one of the expensive thing is the bandwidth itself. Okay? So you know that in wireless communication, we actually use the frequency band. Okay? And this frequency band is being managed by some organization in the world, or perhaps in Malaysia. We have what we call Multimedia Commission and Communication, where you have this frequency band is being managed, and is considered as expensive, right? So they will allocate the bandwidth if you request it. Okay? So for instance, in our wireless communication, say Celcom or DG or perhaps Maxis, they will need to acquire a certain bandwidth that they can perform their network, okay, or data transfer. but then they have to buy for it, and then very limited, and it's very congested between within that specific frequency band. So it's very expensive to manage your bandwidth. So that is why you can see that there's a different technique how you can optimize the bandwidth. Okay, so we have, for instance, the term like OFDM, okay, and so forth, so that it can actually optimize the small but expensive bandwidth. Okay, so these are the things that perhaps being defined. So this is how you can look if it is being drawn. Okay, whereby if this is your data rate and this is the time that it has to deliver, right? So you can have this peak data rate. Okay, is actually the maximum size of data rate that you can deliver. Then the average data rate, okay, and then what is the maximum burst size, right? So this is with respect to time. This is the data rate that you can have defined for it. Okay. And this is what I mentioned in some devices or some services. Okay, they will acquire different types of data traffic. Okay, so there are three traffic profiles that we can say that the first one is what we call constant rate. It means that the data rate is constant throughout the time. Okay, so you have a flat data transfer. Okay, then you can also have this variable bit rate. Okay, where you can have vary of your data rate from time to time. Okay, this can be example for your video call. For your voice call. Basically, you don't need to have a variable data. Okay, so your voice call is a constant data transfer using this constant bit rate. Whereas if you do your streaming or perhaps your video call, you need to have this because video, you have much more data to be delivered. Okay, and this is the characteristic of the video transfer. And then you have a bursty one, means that at one time you have a lot of data to be delivered. Then another time there's empty, nothing to be sent. Okay, and then come again one time that you need to have higher data. Okay, so this is an example of a web traffic where you browse some services or some website, and at that time you need to request picture. Then there's a data to be transferred. Then suddenly you are enjoying the pictures or whatsoever. Then later on, perhaps you need to download another picture from the website. Then you have this transfer. Okay, so these are the traffic. So with this traffic, basically application network, they can design the quality of service based on this specific traffic and specific services, so that they're able to make sure that network is not being congested by these specific devices or services. Okay. So congestion in a network may occur if the load on the network is greater than the capacity of the network. Okay, so you don't want to burden the network with the big number of packets or big number of users, okay, that it cannot handle. Okay, so you want to make sure that if you have 1 gigabit of network, then you'll be able to deliver the 1 gigabit without having to interrupt any of the services within that transfer. And the congestion control refers to the mechanism and techniques to control the congestion and keep the load below the capacity. And this basically will happen when you have this congestion. So you'll be able to make sure that the services is not being interrupted, okay, by having this mechanism to release the congestion itself. One of the techniques that you use in your network, okay, or router or switches, okay, is that you have a buffer. Okay, so a buffer is a temporary storage. Either is from the incoming or the outgoing. Okay, so you can also see it as a queue. So buffer, but buffer is actually limited. So if you have buffer of 100 megabits, okay, so perhaps if your packet that received by the buffer is more than that. Okay, so what it did is that basically it will drop the packet. Okay, so you need to manage this buffer, not just the network. Okay, but this buffer will actually an intermediate medium before you congest your network. Okay, perhaps before you send your data to your network. So this buffer will actually do some miracles in order to make sure that your packet doesn't overwhelm the network. Okay, so in buffer you can have what we call inbound and outbound. Okay, input output buffer. Okay, and again, as mentioned, this is the mechanism that can either prevent congestion before it happens and remove congestion after it happens. Okay, and we define it as two different terminology. One is what we call open loop. Okay, if you can remember this, open loop is for prevention, whereas closed loop is for removal. Okay, so before it happens, you have to prevent it. So that is called open loop. But if it's already happening, so how do you manage it? So this is the removal part. Okay. So how do you make sure that for open loop mechanism or the categories? So for open loop, before anything happens, you need to manage the retransmission policy. Okay. So how do you manage the retransmission policy? How do you manage the windows policy? How do you manage the acknowledgement policy, the disclosure policy, and emission policy? So these are the one that you can implement to make sure that your network doesn't overwhelm. Okay. So later we'll see that like a Windows policy, we have what we call slow start Windows policy, where we start with a single window size, then we double it up 2, 4, 8, and so forth. Okay. So it will actually depends on the current network. Okay, so if when you send with that slow start and you get that maximum or optimum size of window, then that is the maximum limit that you can transfer. So that if you go beyond, then there's a possibility that it will congest the network. Okay, and so forth. And then for the closed loop policy, closed loop category, back pressure, choke packet, implication signaling, and explicit signaling. Okay, so these are the things that you can differentiate between open loop and closed loop. Okay, and mind you again that this one open loop, it means that before anything happened, before the congestion happened, whereas for the closed loop, when it happened, what do you want to do? Okay, so this one before, okay, you stop it before it happening, and this closed loop will handle when the traffic of congestion happen. Okay, so these are the explanation for the open loop policies. Okay, right, for retransmission policy. Okay, retransmission policy and the retransmission timer must be designed to optimize efficiency at the same time prevent congestion. Okay, so you have to design in order to make sure that perhaps close to zero retransmission, because retransmission will actually delay the service of any type of application. So if possible, you wanted to make sure that the retransmission policy as low as you can be. Okay? And then we also have the window policy, where you can see that the selective repeat window tries to send the specific packet that has lost or corrupted. Okay? And acknowledgement policy, sending fewer acknowledgements impose less load to the network. Okay? So you have to make sure that you don't really send many packets, especially on the acknowledgement. Okay? So you can see that one of the example that we have in sliding windows protocol, where you acknowledge the cumulative packet, okay, rather than you acknowledge each and every packet that you receive. Okay? And then discarding policy, a good discarding policy by the router may prevent congestion, at the same time may not harm the integrity of the transmission, right? For example, an audio transmission, if the policy is to discard less sensitive packet, when congestion is likely to happen, the quality of sound is still preserved and congestion is prevented and elevated. So you have to look into different applications. Like for video transmission, if you have congestion during your video transmission, perhaps what you can do is that you can like drop some of the packet, because in video transmission is a continuous. When you send, is a frame by frame of your videos, right? So perhaps if you drop one of the packet, one of the frame of the video, perhaps it doesn't or it doesn't change. Okay, so that is not critical. Okay, so you have to make sure that the discarding policy is not that critical. But when you drop packet, where for audio, for instance, okay, so say that when I talk something and then suddenly there's a packet drop, and you drop the packet that explaining things, okay, so there's a possibility that you misunderstood or misunderstand. So that is not a good policy. Okay, so you have to actually look into one of the application and make sure that your policy, discarding policy, doesn't actually giving problem to the application itself. And then admission policy, okay, first check the route source requirement of a flow before admitting to the network, and the router can deny establishing a virtual circuit connection if there is congestion in the network and if there's a possibility of future congestion. Okay, so this one, this method is basically when they started to get into new conversation, right? So where you need to do this connection setup. So they will check, okay, between the network and also the applications requirement. If it doesn't match, then you need to make sure that perhaps the network or the communication can be stopped beforehand, right? So these are open loop congestion control policy. Whereas for closed loop control policy, back pressure method, okay. So this method is that a congested node stop receiving data from the immediate upstream node or nodes, okay. And back pressure is the node-to-node congestion control that start with the node and propagate in the opposite direction of data flow to the source. Okay? So basically, is that in this mechanism is that when you send a data and you get until one point that you identified there's a really heavy congestion. So what you do is that you send message back to node by node until using the same path that it goes at the beginning. Okay, so you reverse the path and you will actually inform all the nodes about this congestion, right? So this is how it looks like. Okay, you actually from the node that you identified there's a congestion, then you will back pressure it so that each and every node that at this will actually identify there's a heavy traffic incoming. And then you have a choke packet. Okay, for compared to the back pressure just now, there where for the back pressure it will inform all the nodes. Okay, but for a choke packet, it's directly to the source. Okay, so the choke packet is a packet sent by the node to the source of the information of the congestion. Whereas for the pressure, the warning is from one node to its upstream node, whereas the choke packet is from the node to the source directly. Okay, so that's the difference between the back pressure and also the choke packet. And for the congestion control, okay, that being used in TCP, they will indicate some size. Okay, for here it says that the sender has two pieces of information: the receiver advertised video size (RWND) and the congestion video size. Okay, so actual video size that being implemented is minimum between the advertised video size and the congestion video size. Yeah, whichever minimum, then it will take it. Okay? And you can see this is how it have it. And one of the things that I've mentioned is that for this video size or sliding videos protocol is to use what we call a slow start phase, right? So what is this slow start phase? Basically, it will send or the window size will increase if there is no problem on the network. Okay? So here you can see this diagram is that it will start with 2 power of 0, okay? Which is 1. So it sends 1 packet at one time. receive the acknowledgement, then it increase it to double of the size. Okay, so 2 to the power of 1 is 2. So then you send 2 packets, and then you get acknowledgement of those 2 packets, and you increase it to 4 and then 8. Okay, so in the slow start algorithm, the size of the congestion window increase exponentially until it reach the threshold. Okay, so this one, it doesn't reach the threshold, and it will continue. Okay. And then when you reach the threshold, which basically, okay, so in the congestion avoidance algorithm, the size of the congestion window increase additively until congestion is detected. Okay, so this is when you perhaps you try or you have some indication that there's a congestion. So rather than you have a slow start just now, because slow start basically you don't have any information yet. Okay? But if you have this mechanism, basically when at least the threshold where you start with the slow start, but then you have the congestion. Okay? After that, you can start increasing by 1. Okay? So you will increase slowly. Okay? So the congestion increase, the size of the congestion window increase additively until congestion is detected. Okay? So you will increase it 1 by 1 until you see that there's a congestion on that path itself. Okay? So an implementation reacts to congestion detect in one of the following state. If detection is by time up, a new slow start phase is start. If detection is by the 3 acknowledged, a new congestion avoidance phase will start. Okay. So what it means is that if the packet doesn't be received, okay, because when you send the packet, then you will start your TTL, time to live. And if it doesn't receive by the end of the packet, there's a possibility that perhaps the packet loss, okay, is not due to congestion. So you can use the slow start phase. Okay? Whereas if you receive detect by 3 acknowledged and the new congestion avoided is start. Okay? So detection by the 3 acknowledged means that perhaps there's some you detect there's an congestion. So you will start with this congestion avoidance phase, which is you increase 1 by 1. Okay, so this will the flow of it. Okay, and for data flow characteristic, okay, so these are some definition of characteristic that they will use. Okay, basically you have the reliability, delay, jitter, and bandwidth. Okay, so perhaps there's a calculation that we need to make to identify what is the bandwidth. Jitter you cannot calculate, but it's a variable delay actually. Delay perhaps is the time. You can measure the time, okay? And so the reliability. Okay? These are the things. So reliability is the characteristic that a flow state where lack of reliability means losing error packet or enrichment, which entails retransmission. However, the sensitivity of the application program to reliability is not the same, okay? And so forth. So this mentioned that each application has different reliability requirement. Okay? And delay is the time it takes for a flow to go from source to the destination through the link. Okay? So you time from sending to receiving, what is the time? Okay? And basically, in a real network, you don't really measure from sender to receiver, but you will actually send what they call it. You will actually measure the sending and then the acknowledgement. Okay? So from sending and receive the acknowledgement by the sender. Okay? So and again, it can also vary based on the different services that we have. And jitter, as I mentioned, is variable of delay. So a variation of delay for packet belongs to the same flow. What does this represent is that when you send a packet from sender to receiver, right? So you have to pass through all these different nodes, switches, router, and so forth. Okay. So when you send packet number 1, it will perhaps use different path, okay, received by the receiver, acknowledged. Okay. So you record time 1, okay. But when you send another packet, okay, perhaps using the same path or perhaps not using the same path. But what it will measure is that you will have different time taken until you receive the acknowledgement. So when you measure the first one, okay, perhaps different from the second measurement, third one is different, and this is what we call normal characteristic for a network, because you have to pass through different network, you have different traffic at different time. Okay, so with that you also measure the jitter lah. Okay, so jitter is actually the delay variation of delay. Okay, and the bandwidth is the maximum amount of information that can be transmitted along a channel. Okay, so these are the things that you have to inform or you have to discuss between the services and also the network itself. Right. So now you know the congestion, how you manage the congestion, okay? What things that actually that making the congestion happen. Okay. So now we want to look into what we call QoS, short name for quality of service. Okay. So it's just like making sure that when you do or you dine at a restaurant, you want to make sure that the quality of the service is at some level of par. Okay? So you want to make sure that this can be measured, and also if possible, you need to manage. Okay? So you have to manage this. So 4 common methods that can be used to improve the quality of the service: scheduling, traffic shaping, emission control, and the resource reservation. So what does it mean? For scheduling, okay, refers to the way flow are assigned to be processed by switch or router. Okay, and you can use any of these methods. I think some of you perhaps have gone through like the term of FIFO, LIFO, PILO or whatsoever. So this one basically, when you have the packet, okay, basically any packet enter first, then it will go out first. Okay, so before first in, first out. Okay, PILO for instance, first in, last out. Okay, meaning that anything that you receive first, then it will queue, but it will be the last one, right? And then you can also have this priority queuing and weighted fair queuing. Okay, so we'll look into this, right? So for FIFO, basically here, when you receive your perhaps at one node, okay, so you arrive at T1, okay, packet number 1, arrive at T2, packet number 2, arrive at packet number 3, arrive at T4, okay, but then you have to queue lah, okay, so perhaps by T4, the first packet can be sent, okay, and then at T7, the second packet can be sent, and the last packet is sent at T9. Okay? So basically, you have the buffer that you queue whenever the network is ready to be processed, then it will process based on the queue, right? So this will be based on whatever comes first, they will actually process first. Okay? But you can see that there's a delay, because at the router, when the receiver receive at time 1, but it can only be sent at the outer port, okay, at time 4. Same goes for the rest, but it is based on the queue whenever that is received. Right. In FIFO, queuing packet waits in the buffer until the node router is ready to process. If the average arrival rate is higher than the average processing rate, the queue will fill up and the new packet will be discarded. Okay, so the policy is that, as mentioned, if your buffer, since the buffer has some limit, when the buffer already been full, okay, so any new packet, it will actually drop. Okay, so then the sender will need to regenerate. Okay, so we are talking at the sender side itself. Okay, so now they need to queue up, and if it's too much, then they will drop any packet that can make congestion. Whereas for priority queuing, basically when you have any packet, you have to indicate either that they have some priority between that. Okay? So if your mechanism or your packet itself in the header, you can include either the priority information with respect to the different packet, and then you can actually make a queue between those two. Okay, so you can have this higher priority and lower priority. So when you have this higher priority packet received, okay, although it's later than the low priority packet, you can process this first. Okay, so if you look at this timing diagram, your packet with higher priority received at time 1, and then you will send at time 4. It's the first that out. Okay? But you have a packet at time 2, okay? And then you have a packet with higher priority at time 3. So between these two, okay, you will tend to send packet number 2 from the higher priority first. Okay? Then you have packet number 2 and packet number 3. So here, then after some time, you send packet number 1, okay, with low priority. Then between these two, since you already received between these two, so you will send packet number 3 first, then packet number 2. Okay, so this is how you can have higher priority. When do you implement this, or how do you select this? It again, it will be actually based on one is the what type of service, okay, and perhaps one another thing is that what are the requirements that it needs for the network itself. Okay, so this is the priority queuing, and then you can also have the weighted fair queue. Okay, what weighted fair queue means here is that if you have a queue, okay, and you have different weight, okay, meaning that this one, if you receive 3 packets, then send everything because you have a weight of 3. This one, you have a weight of 2. If you receive a 2 packet, then you can send 2 directly. Okay? But this one packet only weight 1, so it means that 1 at a time, and you will actually move it with respect to the circuit itself. Okay? So the first weight, you send 3 packet, then you send 2 packet, 1 packet. Then if there's no other packet to be sent, then you can skip this. Then also this one has already been sent, you can skip it. Then you can send packet number 2. Then you move to this level again. No packet arriving, then you can send 3. Okay, so with respect that it's much more fairer. Okay, but again, you can also implement this based on the weightage. Okay, so then moving to traffic shaping techniques. Okay, traffic shaping can either use these two, or perhaps you can use both. Okay, basically for leaky bucket, it will give you an average data delivery. Okay, whereas token bucket is based on the token that been generated. Okay, so this is how you look at the leaky bucket. Okay, it's similar to if you do this at your bathroom at home. Okay, so you can have your water dropping into a bucket, but that bucket has perhaps one output, or the water can flow down from one pool. Okay, so although you receive a lot of water, but then the one that flow out is on a consistent manner. Okay, so this and this will look something like this when you have a kind of bursty network. Okay, but then when it put into the bucket, leaky bucket, so what it will send is based on this fixed data, right? So this is how you look at this leaky bucket. And then this is how it process. So a leaky bucket algorithm shape bursty traffic into fixed rate. Okay, so you remember this, that for leaky bucket, it gives you a fixed rate by averaging the data rate, and it may drop the packet if the bucket is full. Okay, so it has a queue of your bucket, and if it's more than the one that generated more than the size of your buffer, then you will remove. And then you have a token bucket. Okay, so the leaky bucket is very restrictive. It does not credit an idle host, whereas for the token bucket algorithm allows idle hosts to accumulate credits for the future in the form of token. Okay, so it gives you some more fair share. Okay, So for each tick of the clock, the system send n token to the bucket, and the system remove one token from every cell of the data set. Okay, or in other words, the host can send bursty data as long as the bucket is not empty. So it means that you can send multiple packets at one go, and but you need to make sure that there's a token within it. Okay, so basically, if you receive any packet, okay, queue, just now you just need to get an overflow. Okay, sorry, not overflow. When you send, you receive the packet, so you will send it at this fixed data rate. But here it depends on the token. Okay, so if you have one token, then you can send. Then you can move to the next token. If the token is still available, then you can continue the transmission. Okay, so the token bucket allows bursty traffic at a regulated maximum rate. Okay, so it will manage the bursty traffic is not too many packets that being sent, but it is based on the token that it receives. So actually, much of the current network, they can actually use this, okay, meaning that when you use this, you can use this token bucket first, and then you can use the leaky bucket on the next processor. And then we also have this resource reservation. Basically, you wanted to make sure that your resource is available. Okay, so you can reserve it. Then when you need that kind of reservation, then you can use it. Okay, so the data flow of data need resources and a buffer, bandwidth, CPU time, and so forth. And the quality of service is improved if these resources are reserved beforehand. For this purpose, a QoS model called integrated service, which depends heavily on the resource reservation, is employed. Okay? But this one will be expensive because you are giving some priority to this specific data. Okay? Perhaps they pay much more, so you can reserve. Because again, I mentioned that the resources is very expensive. Okay? So you have to play around between this and the piece. Okay? And control admission, basically, you want to make sure that before you agree to take any of these services, so you have checked it. Either your network is okay or the device request is matching with the network itself. Okay? So admission control refer to mechanism used by a router or switch to accept or reject a flow based on the predefined parameter called flow specification. So they need to negotiate. So before a router accepts a flow for process, it checks the flow specification to see if capacity and its previous commitments to the other flow can handle the new flow. Okay, so this is just to taking bear in mind. Okay, so you already have something that being services. Okay, but before you have to enter any new services, okay, so you have to check with respect to that. Okay, so this is for admission control, right? So these are the things that we already mentioned. Okay, so for this chapter 12, okay, so we have looked into the different traffic description. Okay, so then we also have defined what is open loop congestion and closed loop congestion. So basically, open loop, making sure that before anything congestion happens, so you have some mechanism to implement. Whereas closed loop congestion control is when things happen, what do you need to do, right? And then we also look at the QoS definition, reliability, delay, and bandwidth. Okay? And then technique to improve the QoS. For instance, you have seen the FIFO priority queuing, weighted pair queuing, traffic shaping techniques, leaky bucket, token bucket, resource reservation, and mission control. And with respect to this implementation, we hope that the congestion control can be managed properly. And if still happen, then we have some mechanism to resolve it to make sure that the packet or the network can deliver the services properly. Okay. Any questions? Any questions so far? No. All right. So Thank you. So if there is no question, uh, perhaps we take a 5 minute break, then I'll come back and we will enter lecture 14, which is on the network management and security. Yeah? So 5 minute break. All right, so we are back. So there is question from Muhammad Imran. Lukman, I already addressed that, as mentioned, that they still have a physical session for this afternoon. So my group of assignments has already been confirmed by you, but it's only 2 people so far. Can I invite more people? And if I do so, do I have to email the new people in my group to say yes? The answer is yes. You can add another 2 people, and you have to email me, and I will send you acknowledgement of them. Okay, it's just like the packet is right. So you just send to the receiver, and then I will acknowledge. Okay. Any other question before we move to the second lecture? So, have we gotten the attendance yet? Yes, I've already shared. If you scroll or even I've already shared this. I've already copied the URL here. That will help you. Okay, so no further question at this moment. So perhaps I can just continue on the next chapter. Right. So this one of the important things about networking, computer networking, or what we call internet networking or whatsoever. So basically, what we want to see, one is on the security part, and the other one is on the network management part. So these two are 2 different things. Management is that how you manage the devices, okay? And you tend to have some information that you need to acquire from all these different devices. Say that you have a server, you have a printer, you have some IoT devices. So you need to manage that, which you can't manage that manually. Okay? So you need to have some software, and then you install some agent. So you have a control software that you have installed agent in all the different devices. Okay, so that it can talk between each other. And if there's any error or if there's any things that need to be highlighted, then the one that manages it will have that information, right? Whereas for security, basically in current world, is one of the major important thing. Okay? How to make sure that you are secured when you are online, right? So we will touch that a bit, okay, and on the network management later now. Right. So we will look into network management system, and then one of the framework that we use is simple network management system protocol. Okay, and then we will like to go on the security part, okay, where we will talk or we will touch on cryptography. Okay, and how does these different layers, okay, help make the whole network secure. Yes, we will look at how you make a secure network at the multiple layers, okay, including the network transport and the application layer. And finally, we will also touch a bit on firewall. Okay, so this one is kind of a protection for you in order to make sure that nothing can harm your network, your devices, or perhaps yourself itself. Okay. All right. So for a network management, where you have to monitor, and what are the things that you need to monitor, is that you need to monitor the network components. Okay? Not just monitor, but you have to do testing, configuring, okay, and troubleshooting the network component so that it meets the set of requirements defined by an organization. Okay? So you tend to have these agents that are doing this automatic kind of management for you. Okay? And this includes the smooth, efficient operation of the network that provide the predefined quality of service for user. Yes, so this is where between the devices will have this information that related to quality of service. Okay? This is where also you will define what is your bit rate, what is your bandwidth that you need, and so forth. Okay? And to accomplish this task, the network management system uses hardware, software, and humans to do this. And the network management system, area of network management system defined by the standards, ISO, where you need to do this configuration management, fault management, performance management, security management, and accounting management. Okay, so these are part of the network management system. Okay, so the first one is the configuration management. So the configuration management system updates the information about the status of each entity and its relation to the entities. And configuration management can be divided into two: reconfiguration and documentation. Okay, so basically, you can see that in a large network, usually made up of hundreds of entities that are physical and logically connected to each other. This entity have an initial configuration when the network is set up, but can change with time. Okay? Desktop computer may be replaced by others, application software may be updated, user may move from one group to another group. So at the beginning, you have this configuration. Okay? So you have to have a document on how the network of your whole entire system, and you have information of the configuration when it starts or the beginning of its setup, right? But later on, you can also have some information of the reconfiguration, and you have to document it. And then for fault management, where it supervises the operation of the management, a fault management system have two subsystems: reactivate fault management and proactive fault management. Okay, so in a reactivate fault management is to detect, isolate, correction, and record faults. Okay? And proactive fault management is trying to prevent fault from occurring. Okay? So you need to have this in mind also, not just in mind, but documented it properly on how to manage if there's any fault or any error. So how do you recover? Okay? So you need to reactivate how to recover for if there's any faulty. Okay? And proactive means that how do you prevent it from happening, or perhaps again happening again. Then performance management monitors and control the network to ensure that it is running as efficient as possible. And this is one of the most important thing is that the performance need to be measured at every time, so that you're able to make sure that your system is working at optimum operation. Okay? So four measurement qualities that need to measure is capacity traffic, throughput, and response time. Okay? So these are the things that you have to measure and you have to record. Okay? And then the security management, where they're responsible for controlling access to the network based on the predefined policy. Okay? And you need to have a security tool such as encryption, authentication, okay? So that you're able to protect your network. Okay? So encryption, basically you wanted to make sure that the information that you send is unreadable. Okay? Authentication is where you want to make sure that the information is being sent by the correct user. Okay? So to authenticate, so meaning that you have to make sure that the sender is the one that really the one that sending the information. Okay? Then you also have this accounting management. Is the control of user access to network resource through charges. Okay? And under accounting management, individual users, department, division, and even project are charged for the service that receive from the network. Okay? So this is for charging purpose. Right? So how do you that? How do you do this management? Okay, one thing is that for record documentation, that are the four things that you perhaps need to have a kind of a information or be filing properly. Okay? So how does the configuration, if there's any configuration changes, this is the document that how it already been changed. And then the fault management basically, it needs to have all the information how to manage if there's any fault system itself. Okay. And one of the things is that where to contact, for instance, the owner of these devices and so forth. So fault management will have all this information, not just on the how you manage the flow, but also on the contact that you need to have. The performance management basically is to measure each and every time how the network is behaving. Okay? Then security management is to make sure that you protect your user within your network. Then you can charge it if you need to do some further charging. Okay? And when it comes to this implementation, one of the protocol that can be used is Simple Network Management Protocol, shortly known as SNMP. Okay? This is different from the one that you have go through in email application, which is on the application level. That is SMTP, right? Simple Management Transfer Protocol, SMTP. This one is SNMP. So this is two different protocols. Okay. A simple network management protocol is a framework for managing device and internet using TCP/IP protocol suite. Okay. It's defined in IETF. Okay. So there's IETF different terms or different documentation for this. Okay. It provides a set of fundamental operations for monitoring and maintaining an internet. Okay. So this is providing the protocol, and also it provides how you can manage your network itself. Right. So what's the concept of SNMP? Basically, you have a manager that manages it. So you have a software, for instance, and then you install some agent on your devices, okay? And you just manage through your agent. So SNMP uses the concept of manager and agent. A manager usually a host control and monitor a set of agents, usually routers. Okay, so and how you manage the information is through this SNMP packet. Okay. So SNMP is an application level protocol. Okay, so similar to SMTP, okay, which is on application. SNMP also is on the application level, okay, in which a few manager routers host control a set of agent routers. Okay. It can be used in a heterogeneous internet made of different LAN and WAN connected by routers made by different manufacturers. Okay, because you can just install the agent. It's kind of a software that you install on the devices that can manage it. And the manager is a host that runs the SNMP client program, and the agent is the router or host that runs the SNMP server program. And management is achieved through simple interaction between the managers and agent. Okay, so this is manager and agent communication. Okay, and this agent keeps the performance information in the database, and the manager has access to the values of in the database. Okay, so when on a daily basis, so the agent will acquire all the information that it needs, okay, stored into in that device itself. Then when the manager needs that information, it will acquire from all these agents. Okay? For example, a router can store an appropriate values of number of packets received and forwarded. The manager can fetch and compare the values of two variables to see if the router is congestion or not. Okay? Agent can also contribute to the management process, where the server program running on the agent can check the environment, and if it notices something unusual, it can warn a warning message called a trap to the manager. Okay, so this can be used to manage traffic congestion. Okay, so it's either the manager, it can compare the current information with the one that the manager has. Okay, or perhaps the agent itself can give some indication to the controller or manager that something is currently happening. So SNMP manage with three basic ideas. A manage check an agent by requesting information that reflects to the behavior of the agent. Okay, so this is clear. A manager force an agent to perform a task by resetting values in the agent database. So this one, the first one is just getting the information. This one is where you request the agent to perform some extra tasks. Okay? And an agent contributes to the management process by warning the manager of unusual situation. Okay, so this one is also clear, is that the agent can also give some indication to the manager on the current situation of the network. Okay. And to perform this, it is two structure. Okay. One is what we call SMI, and the other one is MPI. Men in black. This is management information base. The SMI is structure of management information. Okay. SNMP needs to have this. Okay. So in other words, management on the internet is done through the cooperation of this protocol, SNMP, SMI, and MIB. So you have all these three protocols that that communicate with each other. Okay. So what are these? Okay. The role of SNMP define the format of packet exchange between the manager and the agent, and erase and change the status value of object variables in SNMP packet. Okay, so this is where how the environment between the agent and manager that being exchanged. Okay. Whereas the role of SMI define the general rules of naming object, define object type including range and length, and show how to encode objects and value. Okay, so it defines the rule, how you give the name of the object, okay, or perhaps you need to know what's the length and so forth. So it defines. Where the role of MIB creates a collection of name objects, their types and their relationship to each other in an entity to be managed. This one is much more like a database, right? So this one defined, and this one will be kind of a database kind of function. So assume that a manager station wants to send a message to an agent station to find the number of UDP datagram received by the agent. The step involved are shown in the next figure, which is the one. MIB is responsible to find the object that holds the number of UDP user datagram. Okay, so this is the database. SMI will, with the help of another embedded protocol, respond to encode the name of the object. So this is the definition. And SNP is responsible for creating a message called get request message and encapsulating and encoded the message. Right. So these are the things where you define the values, okay, and then what is the object, and then encapsulate the message and send it to the agent itself. Right. So that is about how you manage the network. Yes, so you use the SNMP plus the MIB and the SIM, right? So you will be able to identify or to give some indication either the server, the printer, or the IoT devices is having problem or whatsoever by having this management control. Okay. Next, we want to move to computer security goals, okay, or on computer securities. Okay, it's very important in current situation, whereby every moment of time you are actually being exposed to any threat, okay, including the threat from the one that wanted to get your account number, the one want to hack you or wanted to make you feel bad or whatsoever. Okay, so you need to have this measurement or this level of security. Okay, and we wanted to see how does the network prevent us, right? So we want to go to computer security part. Okay, so in computer security, you want to make sure that the network, okay, has confidentiality, has integrity and availability. Okay, so these are the goal. Okay, so three goals of security: confidentiality, integrity, and availability can be tracked. So basically, available, you want to make sure that network is always available and available in the way that we want it to be secure. Integrity, you want to make sure that all the user within that network is genuine, kind of user with the respective information is genuine from that user. Confidentiality means that if the communication is between two parties, you want to make sure that it is not being tapped or whatsoever. Okay, so you need to have these three goals in this network security, right? Okay, so threat of confidentiality, snooping, traffic analysis means that there's a possibility that a secure attack can be done, okay, by snooping, hearing, okay, or it can also use this traffic analysis to actually get some details of it, okay. And then threat of integrity, modification, masquerading, replying, repudiation. Okay, so these are also some of the threats that usually can be done on the network. And availability, based on what we call denial of service. If you have a lot of packet that being sent to the network, so it flood the network. So these are one of the attacks that you can see where you've been denied from the service because the network is already being flooded with a lot of packets. Okay, so these are the things that you need to secure. Okay, and to make sure that your message is not being perhaps read properly by any unwanted user. Okay, one of the things that we can use is we call cryptography. Okay, so cryptography is where you making sure that the information that you send is being covered up, okay? Or so that when it sends, nobody will understand it. Okay? But then when received by the one that supposedly to receive, you're able to decrypt it, and then you will get this basic information. Okay, so this one is very much important, especially in army, right? So in for army, when you send messages, you don't want your enemy to get the information and perhaps they can bypass you. Okay, so there's a possibility of this. Okay, and this cryptography will help you to make sure that perhaps the army receive it is kind of garbage information, so it doesn't understand what the information is. Okay, so confidentiality can be achieved using ciphers, encryption, and decryption. So cryptography means that secret writing, and cipher can be divided into two broad categories: symmetric key and asymmetric key. So you will see that there are two different types. Okay? One is what we call symmetric key. So in a symmetric key, you encrypt and decrypt using the same key. Okay? So here you can say that when you have this plain text or information, you want to make sure that the one that being sent not being the information is not being tampered or not being readable by the intermediate user or perhaps then the one that wants to tap you. Okay, so you encrypt using some key. Okay, and this is the cipher text. Okay, and received by the receiver. Okay, and you use the same key to decrypt it. Okay, so one of the problem is that if the attacker wanted to get this information, if it can get the shared key, then it will be having difficulty, okay? Because how do you want to share the key? So when you generate here, you want to make sure that the key is the one for the sender. Okay? You have the same key for the receiver. So in between, or if you have difficulty to share, or if you want to share it through the network itself, then there's a possibility that someone will store the key itself, right? So symmetrically, and achievement as locking and unlocking with the same key. Okay, so that's the very basic thing. Whereas for asymmetric, your receiver actually it will have two different keys. Okay, so one is what we call the public key, and the other one is the private key. So it will generate not symmetry, two keys that actually can work together, and you will send the key publicly. So any sender wanted to send the message to that specific user and want to encrypt the message, they can use the public key. So anyone can have the public key. So it will encrypt with respect to the public key, which being shared throughout the network. Okay, but the private key is being saved by the receiver itself, right? So when it sends the encryption ciphertext received by the receiver, if you use the same public key, you will be able to decipher. Okay, but if you use the private key, then you can decrypt it. Okay, so that you're able to find what is the actual information. Okay, so this one is much better in the sense that you can share with everyone the public key, whereas the private key you will save it on your own. So here it says locking and unlocking in accessibility key with a crypto system. You can use two keys. One is the public key, so you encrypt it with public key, but you decrypt it with this private key. Okay, so public key lock, the private key unlock. And then internet security. So now you can encrypt your information, but another thing is that how do you protect your datagram or information from the upper layer up to your transport layer? Okay, so we will try to see. So we want to see on the network layer, transport layer, and application layer, how is the security of this different layer? Okay, so common structure for these three security protocol is that you wanted to encrypt it from the application layer up to the network layer itself. In network layer, we have what we call IP security or shortly known IPsec. Okay? So at the network layer, security is applied between two hosts, two routers, or host and a router. And the purpose of this network layer security is to protect those applications that use the service of the network layer directly. Okay? So IP security is a collection of protocol designed by the IETF to provide security for a packet at the network level. Okay, so this on the network layer itself, it has this IPsec. Okay? So IPsec is designed to provide security at the network layer. Okay, so IPsec helps to create authenticated and confidential packet for the IP layer. So you have this IPsec that we use in this IP or the network layer itself. But for the IPsec itself, there are two modes. One is what we call transport mode, and the other one is the tunnel mode, right? So in this transport and tunnel mode, basically you have different methods. So in IPsec protocol operate in the transport mode, IPsec protects what is delivered from the transport layer to the network layer. So anything that from the above going down to the network layer, it will be protected. Okay? Or in other words, the transport mode protects the network layer payload, and the payload is to be encapsulated in the network layer. Okay, but it does not protect the IP header, right? So it means that the transport mode does not protect the whole IP packet. It protects only the packet from the transport layer itself. Whereas for the tunnel mode, in the tunnel mode, IPsec protects the entire IP packet, including the IP header. So that's the difference. And it applies IPsec method to the entire packet and then adds to a new IP header. Okay, so this is how it's represented. Okay, for the transport mode, it only protect the transport layer payload itself, okay, but not the IP header. Okay, whereas here you will actually secure the IP header, okay, with respect to the tunnel mode itself. So IPsec in the transport mode does not protect an IP header. Okay, so that's the difference between those. It only protects the information coming from the transport layer, and it's normally used when we need to have host-to-host protection of data. Okay, so that is between end-to-end. Host-to-host between the devices. Okay. And IPsec in tunnel mode protects the original IP header. It protects the entire IP packet. Where the tunnel mode is normally used, between two routers, between two hosts, or between a host and a router, and between a router and a host. Okay, so this is much more bigger area to be covered. And it has two different types of protocols. One is called AH, authentication failure, okay, and also ESP, encapsulating security failure. So in AH, it provides source authentication and data integrity, but not privacy. Whereas ESP provides source authentication, data integrity, and privacy. Okay? So this is the IPsec service between AH and ESP. Okay? And then you want to go to the transport layer. Just now is on the network layer. Okay? In the transport layer, you have the SSL and TSL. Okay? So SSL stands for Secured Socket Layer, okay? Whereas TSL represents the Transport Layer Security. Okay? So there are two different protocols. So security at the transport layer provides security for the application layer from the upper layer, which is application, which uses the service of TCP as the connection-oriented protocol. So for the secure socket layer, which is designed to provide security and comprehension service to data generated from the application layer, and the data received from the application layer are compressed and signed and encrypted, and data that pass to a reliable transport layer such as TCP, which then you have the Netscape that developed in 1994. Whereas the transport layer security is the IETF that the Michelle. Okay, so this they will use the encryption from the upper layer to the transport layer. Okay, so you have this with respect to the SSL and also TSL. Then for the application layer, okay, where we can say that IPsec of FSL, we assume that the two parties create a session between them and receive data info directed. Sending email is a one-time activity, and email there is no session. An example of protocol that provides service, security service for email is pretty good privacy and secured multi-purpose mail extension. So this is for email, email security. So you need to actually do or use this protocol to protect your application based on your email security. So you have the pretty good privacy, okay, invented by Phil Zimmerman to provide email with privacy, integrity, and authentication, okay, where PGP can be used to create secure the email message, and then you can also use the SMIME to enhance the multi-purpose internet access protocol. So this is for email, right? And that is between the layers. Okay, so each and every layer, you try to make sure that there's a protection to make sure that authentication, integrity, and also the three components that mentioned at the beginning just now for security. Okay. Then the next thing that you can protect is that for your network, you can have what we call firewall. Okay. So this idea is based on when you have a castle. So when at one time when you want to track, you want to protect your castle. Okay. So you want to make sure that nobody can get in. Okay, but you can go out, but nobody can get in a very simple or not that. Basically, you want to make sure that you can protect your end within the network itself. Okay, right? So you can use this what we call term firewall. Okay, it can be a software, it can be a device. Okay, so you can have a device, a firewall that located between your after your router. Okay, before enter your network, you have a firewall, right? Or you can have your application firewall itself that be inserted on your device. Okay? So how does firewall perform? Is that it controls the access of your packet. Okay? So a firewall is a device installed between the internal network and of an organization and the rest of the network. It designate to forward some packet and filter others. Okay, so you can have your own policy on what can be in and what can be out. Okay, or both direction. Okay, so you will protect your network, okay, which is your actual site, okay, and then things that are outgoing. So this will be the ultimate protection of your network. A firewall can be used as a packet filter, okay, where there are two functions. One is as a packet filter, means that it will manage packet by packet, where it can forward or block packet based on the information of the network layer and the transport layer here. Okay. So what are the things that you can filter out is the source and destination IP address, source and destination port address, and type of protocol. So it means that you can block, okay, anything that comes under UDP, you can block, okay, or perhaps on the port, anything that comes from port 80, you can block, okay, or perhaps here anything that sent to this specific IP address, you will be allowed, okay, and packet filter firewall is a router that uses a filter table to decide which packet must be discarded, not forwarded. Okay, so this one you have to make policies for it, and you have to implement it onto your firewall. Okay, so for example, if you have a packet filter firewall, here for interface one, if you have this source port IP, you block. And this one means that any information, okay, but if you have the source IP, okay, so you want to block. Whereas for this line, if you have any packet that destined for port 23, you block. Whereas here, with the interface of one, any destination IP with this address, you want to block. And then for interface 2, anything that has destination port 80, you want to block. Okay, so this can be done by configuring. You can yourself can configure it. And finally, you have this what we call proxy firewall. Okay, so a packet filter is based on the information available on the network layer and the transport header. Okay, however, sometimes we need to filter a message based on the information. Okay, so if you have to actually filter on the information, you have to use this proxy firewall. Okay, so proxy firewall stands between customer computer and corporate computer. Okay? So when the user client process send a message, the application gateway runs the server process to receive the request. Then the server open the backend at the application level and find out if this request is legitimate or not. If it is, then the server acts as a client process and send the message to the real server in corporation. If it's not, the message is dropped, okay, and the request of the external users are filtered based on the content and the application layer, right? So here, anything that received by the receiver, okay, so it will go to this proxy firewall first, okay, and it will need to see on the information itself. If it's okay, then it will go to the actual server, or else it will rebound and say that there is an error. Okay, so that is how proxy firewalls being used. So a packet filter firewall filter at the network and transport layer. Okay, so based on the whatever information that you receive from the network and transport layer, for instance, you have the IP address, you have the port, okay, and so forth. Okay. Whereas the proxy firewall filter at the application layer. Okay, so this is the difference between those. So with respect to that, okay, so we now have covered the network management. Okay. Also, we have done the cryptography, where it's to make the information garbage to everyone else except for the intended receiver. Then we also look at how your network is being protected at the network layer, transport layer, and also the application layer. And then the ultimate protection is firewall from outside. Okay, but mind you that this firewall will only limit if you pass through that firewall. Anything that from inside, so for instance, we call it Trojan horse, right? So when the threat is from inside itself, where you have to manage it differently, because firewall will only protect you from outside. Okay? So I open for any question if you have. Muhammad Imran said that anyone want to join my group for the assignment? please WhatsApp Imran and also Haris, right? Those who haven't had any group, then you have to you can communicate with Imran and Haris. I think there are still few students that haven't yet or informed me on their grouping. I think there's still around 20 to 30 number of students. Okay, so please make sure that you communicate with me on your group members. Any other question? And still, since we still have time and there is no question, perhaps I can cover a bit on tutorial 12, right? Because I haven't covered this on my lab. So in tutorial 12, with respect to the last lecture, okay? So how congestion control and quality of service is related? Okay, so basically you can say that in congestion control, the load of the network is prevented from exceeding the capacity, meaning that it's the actual how you prevent it or how you make sure that the congestion doesn't happen lah. So this is on the process, right? Whereas this quality QoS refer to the characteristic of the flow of data to be attained. Okay, so this one is much more towards what are the things that the network needs, the network can support, and what the user can support, and you have to negotiate between the network and the user. If there is a good congestion control, then the QoS is also good and vice versa. Okay, so they have to work together, but in the sense that they are the one is to manage it, and the other one is to give some criteria to the system itself. Okay. Then the next question: what is the difference between open loop congestion control and closed loop congestion control? So the one we have already mentioned for open loop, it means that before it happened, right? Okay, so you want to prevent. Whereas closed loop, when it's already happened, how do you manage this, right? So this is the difference. Open loop congestion control policies try to prevent. Okay, whereas the closed loop congestion control policies is trying to elevate the effort of congestion. Then name the policies that can prevent congestion and policies that elevate congestion. So these are the things I cannot remember this. Okay, that can prevent a good retransmission policy, representative windows, enrichment policy, discarded policy, and emission policy. Whereas congestion can be elevated by the back measure and choke point that at this instantly itself. The next question: what are the 4 general techniques to improve QoS? Okay, so you need to have the scheduling, traffic shaping, and mission control, and the resource preservation. Okay, so that is part of the improvement. Question 5: what is traffic shaping? Name 2 methods to shape this traffic. This is with respect to the token market and the leaky market. Okay, so these are the 2 different types. Okay, so traffic shaping, known as the packet shaping, is a type of network management for the manipulation and prioritization of the network traffic to reduce the effect of heavy use cases with affecting other users. Okay, so this one you can define your own. Okay, but the 2 methods is the leaky bucket and also the token bucket. Then explain what is DNS, is the domain name system. All right. So it's basically it's the one that giving you the addresses that matching with the IP address. Okay? So it's a directory of domain name that can translate into IP addresses. So it match, because you don't remember IP address, you can remember names. Right? Okay, so that is the DNS. So what is the advantage of hierarchical namespace over flat namespace for a system? Basically, you can see that it's much more quicker to search. Okay? So it's much more faster to search in a flat structure compared to in hierarchical compared to this flat structure. Okay? And then compare between FTA, MFA on the agent. Okay? So I think this one you can skip. Explain the use of MIME protocol. This is for attention for your email. Okay. multi-purpose internet email session, because at the beginning email is for is a plain text. Okay? But if you want to include some other medium, okay, so you need to also have this extension on your email header, right? This is for my one, right? So that will be it. Zaman. So, sir, we have class at 3 p.m. I think this is my third time I answer this, meaning that you are not here at the beginning, at the middle. Okay. Zaman, yes, we have a physical class at this week on 3 p.m. Any other question? No? Is that okay? So for those who wanted to have a replacement for your quiz, okay, so please stay back after this. I'll give you a 10-minute quiz, which is quiz 5, so that you're able to top up on the quizzes that you didn't attend, right? And I would like to thank everyone for your cooperation, and I hope that everyone can start doing your assignments and also start doing your lab test, right? So that we can finish, or I can mark it accordingly, okay? Because we have some period of time that I need to enter the marks, okay? So if you wanted to make sure that your mark is properly inserted or into the system, we need to adhere to the time, right? So if you have any question, do email me, right? If you think that you need some extra briefing or whatsoever, I will try to do that, but that one will be virtually. Okay? So I can address that later on. Okay? Any other question? If not, again, thank you very much. I would like to say sorry if I did anything wrong to you guys. Okay? And I hope that we can meet on another session or another subject. Okay? So I hope that you guys will excel in whatever that you will be doing, right? Okay, Aisha, thank you. Right. Okay, so those who wanted to have the quiz 5, okay, please stay. The rest, thank you, and you can leave. Bye, and have a very nice day.